This is my lab 4 about bar magnets. Here's the introduction. The purpose of this lab is to explore the magnetic field of a bar magnet. We observed how the change in distance impacted the magnetic field of the bar magnet. The goal was to compare the magnetic field at the values on axis and off axis. The system in this lab was the bar magnet and the surrounding was the outside area. Some assumptions are there are no other magnetic fields interacting with the phone besides the magnet and the earth. The bar magnet has a magnetic dipole and the magnetic field decreases as distance increases. The K is 3.543 e to the negative 6. The N value is negative 2.3224 and the magnetic dipole moment was found to be 1.724. And here are the physics principles used in this lab. The Biot-Savart law, and here's the formula for that. On the left, the magnetic field created by a steady electric current. The field at a point is proportional to the current and inversely proportional to the distance squared. And then the magnetic field of a dipole formula, seen on the left, and I'm going to describe it here. The field created by a magnetic dipole, typically a small current loop or a bar magnet. In this case, strong field near the dipole and weaker farther from the dipole. Here's the last physics principle used. This is the distance dependence formula. The field strength decreases with the increase in distance. Inverse square law for a long straight current, and inverse cube for a field far from the magnetic dipole. The procedure used in this lab was we made sure the phone is oriented so the magnetometer is perpendicular to the Earth's magnetic field. We identified the location of the magnetometer within the phone being used. And we measured the distance between the magnetometer for the parallel axis and perpendicular axis. And as you can see, those are the pictures to the right of what was going on in the lab. The setup process included these materials. We needed a bar magnet, a phone with a magnetometer sensor, meter sticks to measure the distance, the magnetometer app, and pieces of tape to hold the phone in place. And as you can see, this is our group's data table. These are the distances averaged for R20, and then as you can see, the R's get bigger, and then the distances would get slightly smaller. And for the table on the right, that's a graph of what our data would look like with ln, bx, and ln r. And the y was negative 2.57x minus 15.13. And that was like the slope of the line. And now onto the calculations. So I used the B-bar formula to find n. And that was negative 2.422 ln k, and then k was 3.65 e to the negative 7, and then kr to the n was 1.83. And now here's the off-axis data. So as you can see, all the data is averaged. So the d-perp was about 0.182. By Earth, it was about 0.000052, and then the D was 0.257, about BX was 0.0024, and then you can read the other data points. Now onto the Python code that allowed me to calculate everything. So the mu mag was 1.83, and the magnet.mu was the mu mag times mu hat. And then I defined the dipole using mu and r, and I found the x component, the y component, and z component. My B scale was 2300 and distance was 0.2. And then I used, these are my axes and perpendicular points that I used. And then I set my r-axis equal to the observed axis to create the arrows. And I did that for axis 1 and axis 2. And then d-perp was 0.19. And then this is my computational model. And you can read all the other points. I'm kind of running out of time here. Sources of error. There are other magnetic fields present. It is hard to find the exact location of the magnetometer. Errors when measuring occurs, moving the phone during measuring process? Line up north axis. What if the meter stick was placed at an intermediate angle? The Earth's magnetic field would interact with the bar magnet unevenly, causing inconsistent measurements. The second what if two magnets were placed end to end, the magnetic field strength would increase, would cause stronger readings at all points. But the field orientation would remain unchanged. And thank you for listening.